So let's extend our printer example a little bit further here, and let's look at polymorphism. So what we are going to do here to set this up is we are going to go into our machine class, and we are going to basically make polymorphic behavior on this turn on method. And the way that we are going to be able to detect this is we are going to print out when the machine turns on a certain message. And we'll print out a different message when the printer turns on. So we will do a system.out.println, and we will say machine is on. So now what we can do to demonstrate this is we will go ahead and create our printer, but the way we are going to create our printer here is we are going to use a reference to machine. So instead of creating our variable type as printer, we are going to use machine. Since the printer is as type of machine, we can just actually use the printer or the machine. This machine variable can hold either a printer or a machine. Anything that inherits from machine. Anything that is a machine can be held by this variable. So we are going to actually create a new printer here. Even though this code is going to act on it as if it's a machine, and we will call machine.turnOn. So let's go ahead and run this. And you can see that machine is on is printed because printer doesn't have a turn on method. It's using the one that's inside the machine. Now let's see how we can actually make this polymorphic. If I go into our printer class and I override, which is to create a new implementation for the turn on method, then we should see the turn on method for the printer is going to be called instead of the one from machine when you are using a type of printer. And in Java, the way that we override a method is we use this attribute here, or this annotation in Java called override. And you don't actually have to use this, but this makes it so the compiler will check to make sure that when you put it here, if you don't override a method that actually exists, if your override isn't going to work, it's going to give you a warning. It's going to give you an error. So I'm going to create a method called turnOn. And it has to be the exact same method signature that exists in the parent. And in Java, all methods are virtual. What that means is that I don't have to tell the compiler that this method can be overwritten. That we can have a method that is going to override this in our subclasses. And so by default, all methods are virtual. So this method is going to be called if the type is of printer. So let's go ahead and change this turn on. Let's make sure that we call our super.turnOn, so that it still does actually turn on the printer. But let's change our message here, and let's add an additional message besides what was happening in the machine. Let's go ahead and do system.out.println. And we will print warming up print engine. And let's go ahead and change the order here so that we are actually warming up the print engine before we actually turn on the machine. So now I will go ahead and run this and see what happens, and we still have a reference to a machine here, but because the printer is printer, the type is printer, it's going to use the printer's turn on method. So you can see that it said warming up print engine and then machine is on. So it has actually called this method. Then it determined which method to call based on what this type was. So we can prove that that's true by changing the type here. If instead of a printer we change this to say new machine, and we say true, or we can say false here. Started in the off state, and we run this. You can see that it's now just saying machine is on, so it's actually calling the method inside machine, and that's really what polymorphism is. is it's this ability that based on what type this variable is assigned to, even though this variable itself is actually a machine type. It's only a reference to machine type. If this is a printer, if we made this a printer, then the same call here to turn on, we'll call the program method.